Alrighty, everybody. So in recent videos, we've been looking at functions, that idea of plugging in an input and getting out an output. We are going to, over the next several videos, going to be looking specifically at linear functions. And if you look at the word linear, you're going to think of the word line. So the graphical representation of all linear functions is going to look like a line. In order to get us started with that, we need to remember some key parts about the coordinate plane. So remember that the coordinate plane is divvied up into quadrants. So this first quadrant, both the x values and the y values are positive. In quadrant 2, because it goes counterclockwise, quadrant 2, the x values are negative, the y values are positive. Next, we have quadrant 3, where both the x and the y's are negative. And then, last but not least, we have quadrant 4, where the x is positive, but the y is negative. Okay? Remember, all coordinates are going to be in the order of x comma y. The x comes first, and the y comes second. And we also need to remember our axes. So the horizontal axis, that's our x-axis. And then the vertical, that's our y-axis. Okay, so that's important to remember from the coordinate plane because we're going to be plotting a lot of points. We're going to be graphing these linear functions, so we're going to need to remember those topics and those concepts. Now, if we start to get specific on the linear function, you'll see this blue line here. That is a graphical representation of a linear function. This one happens to be increasing. That won't always be the case. But some key elements I want to talk about are your intercepts. So, this first one, that is your y-intercept. And I'm going to talk more about it over here. So for your y-intercept, in this case, the coordinates of that y-intercept are 0 for your x, and you get out 2 for your y. So with this function, you plug in 0, and you get out 2. Okay? So in general, your y-intercepts are going to be 0 for your x, and whatever your y coordinate is, that's what's going to be your y-intercept. That is where your graph is going to cross the y-axis. Okay? You'll also notice that we have an x-intercept. So the x-intercept happens to be right here. So that is our x-intercept. So let's go into more detail. Over here we have our x-intercept, the coordinates of which on this graphical representation, we plug in -4 for x, and we get out 0 for y. So in general, for linear functions and for graphs in general, the x-intercept, you're going to plug in an x value, and you're going to see where does it cross the x-axis. So you're going to plug in an x value and get out 0 for x. All right, so those are some key elements of the coordinate plane and graphing linear functions. Those intercepts are going to play a big role from here on out. So before we move on and talk about those intercepts a little bit more, we need to figure out how can I graph these. And we're going to graph these using a function table. So if you'll remember, this is a function, y equals -2x plus 5. What we're going to do in order to figure out what does this line look like on the coordinate plane, we're going to figure out some values to plug in for x and see what it gets us out for y. So I always start at this middle box, and I'm going to plug in 0. So if I plug in 0 for x, I've got this work room that I can use. If I plug in 0 for x, that's going to go away, and y is going to equal 5. So that's one of my coordinates, 0, 5, and I can plot that on my graph. Okay. Next, I'm going to plug in 1, and I'm going to see what happens. So I got y equals -2 times 1 plus 5, and either using my calculator or mental math, I'm going to know that simplifies to give me 3. So 1, 3 is also going to be a point on this graph. One more going up. I'm going to plug in 2. Okay, so y equals negative 2 times 2 plus 5. Mental math, that's going to give me out 1. So if I plug in 2, I'm going to get out 1. All right, now I'm also going to go in the opposite direction. So I am going to plug in some negatives here and see what happens. So right before 0, I'm going to plug in negative 1. So y equals negative 2 times negative 1 plus 5. That's going to give me 2 plus 5, which is going to give me 7. So if I plug in negative 1, I'm going to get out 7. And then let's just do one more because I want to make sure this is a straight line. It doesn't start curving or anything like that. I just want to be precise. So I'm going to plug in negative 2 and use my mental math. And I know that that output's going to give me 9. So that point, negative 2, 9, is going to be on this graph. And then all I need to do now is I'm going to connect the dots and form this linear function. So that black line represents y equals negative 2x plus 5. It wants us to plot the points and label the intercepts. So let's label those intercepts now. You'll notice that this point right here, that is my y-intercept because that's where it crosses the y-axis. And then it's not a nice number. It's going to be in between 1, 2, 3, and 4. So this point right there, that's going to be my x-intercept. It's not as nice because it's in between two numbers, but there's still an x-intercept. You will always have a y-intercept and an x-intercept when you're dealing with lines. Okay, let's do one more together because this one gets a little bit trickier. We have f of x equals 3/5 x minus 2. So if I want to think this through, you see that fraction. And fractions can make our numbers very difficult to graph. So I'm still going to start at 0. Because if I plug in 0, then this part's just going to go away, and f of x is going to equal negative 2. So if I plug in 0, I get out negative 2. So that point is going to be on the graph. All right, so now when I think of a number to plug in next, I got to be smart about it because I got to multiply it by that fraction. And so I want to pick numbers that are going to make this denominator of 5 go away. Well, what's going to make that denominator of 5 going to go away? Multiples of 5. So if I plug in 5, okay, and if I actually work this out, so if I find f of 5, I'm going to be doing 3/5 times 5 minus 2. And you'll notice when you multiply those fractions, you're going to take 3 times 5, which is 15. 15 divided by 5, which is 3. So then you're just going to take 3 minus 2, which is going to give you an output of 1. Okay, so when I plugged in 5, the fraction got to go away, and I was dealing with those nice whole numbers again, and I got out 1. So if I plug in 5, I'm going to get out 1. Okay, what's the next multiple after 5? Well, that's 10. Okay, and so f of 10 is going to equal 3/5 times 10 minus 2. Okay, and if I do a little bit of mental math there, 3 times 10 is 30. 30 divided by 5 is 6. 6 minus 2 is 4. So if I plug in 10, I'm going to get out 4. And just for precision's sake, I am going to go in the opposite direction. So instead of plugging in 5, I'm going to plug in negative 5. So f of negative 5 equals 3/5 times negative 5 minus 2. Mental math. I'm going to get negative 3 minus 2, which is going to give me an output of negative 5. So if I plug in negative 5, I'm going to get out negative 5. And then last but not least, I'm going to plug in negative 10. And if I simplify that, this is going to give me negative 8. So if I plug in negative 10, I'm going to get out negative 8. And then all I'm going to do is connect these dots using a straight line. You want to make sure you're being very precise on that straight line. If you have a ruler, great. Just make sure that you're being very, very precise on that. Okay? We want to label our intercepts now. Okay, so label our intercepts here. That's our y-intercept. And once again, our x isn't the nicest value, but it's where it crosses the x-axis. Alrighty, so go ahead, look that over, ask me any questions if you got it, jot it down, and try these next two on your own. Okay, so check your tables. You'll notice in number 1, pick nice values that make that denominator go away. And another thing that I failed to mention is you'll notice in all of these lines so far that we have these arrows. We have these arrows at the end of the lines. That's because these lines are going on for infinity. The domain is negative infinity to infinity, and you can get out any number from negative infinity to infinity as well. So you want to make sure that you're drawing straight lines, that you have arrows at the end of it. Don't get marked off for having silly mistakes, okay? So that's going to wrap it up for this video. In our next video, we'll start looking at intercepts a little bit more.